My name is Dallas, and in this presentation, I will be sharing 4 articles that I found which investigate statistics in the media. I will also be analyzing further tests that can be conducted based on the statistics already presented, and finally, I will note how the statistics found in these articles can be misleading. The first article that I found is titled "Trump Said He Took Hydroxychloroquine to Prevent Coronavirus, but New Study Shows That Doesn't Work." This article is about a research experiment conducted to collect data on COVID-19 patients. The article was reporting on whether or not hydroxychloroquine can prevent the coronavirus after Trump announced that he took hydroxychloroquine to prevent the virus. Before presenting statistics and drawing conclusions on this research, I highlighted key information that needs to be noted. The population is people in the US and Canada exposed to COVID-19. The sample is 821 people in the US and Canada exposed to COVID-19 that they collected. The sampling technique is random sampling, but they do not go into detail on how the participants were randomly chosen and randomly assigned. The article notes that the study was a randomized double-blind clinical control trial, however, and double-blind experiments mean that neither the participants or the researchers know who is receiving the treatment and who is receiving the placebo. It's also important to note the variables. The hydroxychloroquine was an independent variable for one group, taking a placebo drug was an independent variable for another group, and COVID symptoms is the dependent variable being tested. Although how the statistical testing was conducted to come up with the given stats weren't explicit, I thought that hypothesis testing for 2 population proportions would be appropriate. Here you could do the first population is the number of people with symptoms out of those who took hydroxychloroquine, and the second population is the number of people with symptoms out of those who took the placebo. The null hypothesis would be P1 equals P2, so taking hydroxychloroquine versus not taking hydroxychloroquine does not affect the number of people diagnosed with symptoms. The alternative hypothesis, which is the claim, would be that P1 is less than P2, meaning taking hydroxychloroquine leads to less people developing symptoms of COVID-19. And then you can run a 2-prop z-test, type in the desired significance level, and type in successes, which is those with symptoms, in the population of each group. Since the alternative hypothesis is that P1 is less than P2, the graph would be left-tailed. The article shows 12% taking hydroxychloroquine came down with symptoms and 14% taking a placebo came down with symptoms. So the results in the article show no statistical significance. And if researchers used the 2-prop z-test as a way of testing, then they would have found a p-value greater than the significance level, leading them to fail to reject the null and not support the claim that taking hydroxychloroquine decreases symptoms of COVID-19 after exposure. With missing information and room for bias, it's important to note the misleading statistics that can lead to false conclusions. Since the article does not specify how they randomized the participants, there could be biased sampling that was not noted. One example could be choosing participants less exposed or more exposed to support their desired results. There's no way of knowing how many people in the US and Canada are exposed to the coronavirus, so the statistics could be inflated. Researchers also did not test whether the participants came down with the virus, they only tested for side effects, so this could affect the resulting statistics and lead to untrue conclusions. The second article that I investigated was titled "Study Reveals Practice Gap for Patients Undergoing Endometrial Biopsy." The purpose of this sampling research was to evaluate the follow-up care for patients that had a failed endometrial biopsy. This information is important to determine whether or not a second endometrial biopsy is more sufficient and preventative than having to resort to an invasive hysteroscopy/dilation and curettage procedure. Here I've noted the key information. The population is women who have underwent a failed Pipelle endometrial biopsy procedure. The sample is 121 women who have underwent a failed Pipelle endometrial biopsy procedure at a tertiary women's health center between August 2017 and June 2019. The sampling technique is not specified. If I had to guess, I would say that convenient sampling is possible because the woman would have to agree to be a part of the study, and finding this specific sample of women who are also willing to participate does not seem common to me. The 5 variables are undergoing no follow-up procedure, undergoing another Pipelle biopsy, undergoing hysteroscopy or DNC, undergoing another Pipelle biopsy and a DNC, and undergoing other non-invasive testing, which are all discrete quantitative variables. Because the article wants to determine the effectiveness of a second endometrial biopsy procedure before resorting to a more invasive test, one way that they could test this is by using a one-prop z-test for one population. First, the researchers would need to determine what's successful enough. In this example, I chose P being greater than 50%, so your null would be that P equals 50%. We know that the invasive hysteroscopy/DNC procedures are quite effective, but what we want to know is the effectiveness of the second endometrial procedure, and if resorting to that is successful enough to try before resorting to the invasive procedures. So the alternative hypothesis is that P is greater than 50%, which is the claim. Then determine a significance and type in the sample size and successes into the calculator, which is the number of people that had a successful second endometrial biopsy as X out of the number of people being tested after their first failed endometrial biopsy as N. Because the alternative is that P is greater than 0.5, it will be a right-tailed graph. If the p-value is greater than the significance, then hypothetically we would fail to reject the null and reject the claim that a second endometrial biopsy is more effective than having to resort to an invasive hysteroscopy/DNC procedure. If the p-value is less than the significance, then hypothetically we would reject the null and support the claim that a second endometrial biopsy is effective enough to use instead of resorting to an invasive hysteroscopy/DNC procedure. Before drawing conclusions from the statistics presenting in this article, there's important information to note, such as the potential bias. If the 121 women were all taken from the same office, a potential bias could be that the specific office's techniques are faulty for the Pipelle procedure, so these women may not be representative of the population in determining the follow-up care that women in general get when they have a failed endometrial biopsy procedure. And another piece of information that could be misleading is the correlation between a first failed endometrial biopsy and having to get the DNC. Having a failed first procedure could increase the probability of having to get the invasive surgery not because of a mistake the first time, but maybe just because the first procedures are failing for a reason. If this was the case, then a second biopsy, as opposed to secondary invasive procedures, would be an unnecessary procedure. The third article that I investigated was titled "Pesticide Mixtures, a Bigger Problem Than Previously Thought." In this article, the waterways that connect to the Great Barrier Reef Lagoon were sampled for how much pesticides they contain. Researchers conducted the study to understand the pollutants that the waterways are carrying into the Great Reef Barrier, which can impact the aquatic ecosystems. The key information to note is first the population, which is waterways that discharge into the Great Barrier Reef Lagoon. The sample is the 2,600 water samples that researchers took. The sampling technique is not specified. Researchers could have easily used a convenient sample since access to waterways could be limited. I think a better approach would probably be identifying all the waterways and perform a systematic sampling to ensure that each waterway covering all of the access areas have an equal chance of being sampled in case some waterways are closer to pesticide prominent areas than others. And lastly, the variable is the pesticide mixture, which is quantitative continuous. This article shared that the point of testing for pollution is to bring awareness to the public and protect the aquatic organisms. There is a pesticide reduction target in the REEF 2050 Water Quality Improvement Plan, which aims to protect at least 99% of aquatic organisms at the mouth of rivers from the effects of pesticides. The findings in the article that 99.8% of the water samples contain pesticide mixtures should lead to further research on the health of the aquatic life itself. I thought that you could run a hypothesis test for one population, so run a 1-prop z-test from the number of healthy fish out of the population of fish found at the mouth of these 15 waterways. The null is that p equals 0.99, meaning that 99% of fish are healthy. The alternative would be that p is less than 0.99, which is less than the desired health percentage. Then you would determine a significance level for your conclusion and type in the successes and sample size. Since the alternative hypothesis is that p is less than 0.99, it would be a left-tailed graph. If the p-value is greater than the significance, then we would fail to reject the null and support the claim that 99% of fish are healthy. If the p-value is less than the significance, then we reject the null and fail to support the claim that 99% of fish are healthy, which means that pesticides are harming more aquatic life than the pesticide reduction target aims to protect, so action should be taken. Again, there is important information to note to avoid misleading conclusions. Because the researchers did not test every single waterway that discharged into the Great Barrier Reef Lagoon, the 15 that they chose could be close to farms or places that are using pesticides more than isolated waterways. The area which they collected the samples is not specified. This could make the samples selective for being prone to pesticides, which makes the results seem that the amount of pesticides entering the Great Barrier Reef Lagoon is more drastic than it really is, or vice versa, depending on the researcher's desired outcome. If we learn that the samples were truly spread out and random, then we would conclude that these samples are more representative of the population, which is the water entering the Great Barrier Reef Lagoon. The information could be misleading to the public because if someone were trying to make a case to ban or reduce the use of pesticide, then this information would look a lot better in their favor than showing the statistics to include water that is not highly contaminated, or vice versa. The last article that I investigated was titled "Concussion Linked with 57% Higher Risk of Parkinson's in Study." In this article, the researcher wanted to investigate whether or not having had a concussion increases one's chance of developing a neurological disorder later in life, Parkinson's disease being one of them. The population is residents from the Canadian province Manitoba listed on the insurance data from the Manitoba Population Research Repository. The sample is 47,483 people diagnosed with a concussion between 1990 and 2015 taken. The sampling technique was not explicitly identified. Because of the large sample size, I would guess that a convenience sample was used, but I'm unsure for sure what they use. The variables are concussion or no concussion, which are quantitative discrete variables. For this data, determining the correlation between having concussions and developing Parkinson's disease is what researchers are trying to analyze. To determine the correlation, we would use severity of concussion as the first set of data, risk of Parkinson's disease as the second set of data, and run a Lin-Reg test to create a regression analysis using the two sets of data, which would show the correlation between the two variables. I've shown examples of scatter plots and how you can compare the direction and strength to determine if it's strong positive, weak positive, or strong negative correlation. If the p-value is very small, there is sufficient evidence to conclude there is a linear correlation between severity of concussion and risk for Parkinson's disease. But if the p-value is not very small, there is not sufficient evidence to conclude there is a linear correlation between severity of concussion and risk for Parkinson's disease. Lastly, I want to note the important information to be aware of to avoid misleading conclusions. A potential bias for the sampling technique is that if the researchers chose the most conveniently available information that was reported on the insurance data, then they are testing a specific population that may not be representative of the concussions that go unrecorded. For example, they could be at a higher risk for other disorders because their concussions were severe enough to follow up on. Also, insurance data is not reflective of clinical data and can lack relevant details such as family history that could lead to disorders despite history of concussions. Another misleading part of the study is that the people with concussions are being compared with separate people that have not had concussions. This brings in many confounding variables that different people have to compare other than having a concussion or not. The most ideal comparison would be between the same person when not having had a concussion and having a concussion, then determining the different risk for disorders, but this is an unrealistic way to study. From this assignment of investigating statistics in the media, the first thing I can take away is knowledge of 4 different areas of current research being investigated. The second thing I can take away is the statistics in these articles made me curious about further testing that could be conducted, so I learned that statistics can draw so much useful conclusions about the world conveniently. The third thing I can take away is to be very careful when analyzing statistical information given and understanding how it's obtained before trusting the information and drawing conclusions from the statistics.